If you have been, trying to keep up with artificial intelligence in the enterprise space lately, especially sitting here in mid-2026, you are probably feeling completely overwhelmed.
Oh, absolutely. It's just nonstop.
Right. Like there is an absolute flood of announcements, new acronyms, product launches hitting your feed every single week. It is a lot to process.
It's exhausting, honestly.
Yeah. But today's deep dive is designed specifically to cut right through that noise and give you a strategic shortcut.
Yeah, we have gathered a really dense stack of sources for you today.
Lots to get through.
Exactly. We're looking at recent strategic analyses, hyperscaler architecture matrices, and some very revealing open source ecosystem reports.
Stuff you usually wouldn't have time to dig into.
Right. Our goal is to figure out what is actually happening beneath the surface of all these, flashy press releases.
And the mission for this deep dive is to decode a massive but kind of quiet restructuring of enterprise software that is happening right now.
It's huge, yeah.
We are going to chart how the entire industry is abandoning those simple stateless chatbots we all started with and moving into this new era of durable agent runtimes.
Which changes everything about how software is built.
Totally. We'll look at sovereign infrastructure, and we're going to explore some massive new economic challenges. Essentially, we're mapping out the new toll roads of the agentic economy.
I like that framing.
Okay, let's unpack this. Imagine like you're trying to build a massive 50-story corporate headquarters.
Okay, I'm with you.
But instead of using steel beams and poured concrete, your construction crew is trying to hold the building together using Post-it notes and a stopwatch.
That sounds like a disaster waiting to happen.
Right. If the wind blows or if any single task takes longer than 60 seconds, the entire structure just completely collapses.
Well, it sounds like a structural nightmare, but looking at these strategic analyses, that is actually a highly accurate representation of how the enterprise tech world has been trying to build AI over the last couple of years.
Using Post-it notes, basically.
Literally. I mean, we've been using these brittle, temporary software foundations for workloads that actually require massive industrial strength support.
So we need concrete now.
Exactly. To understand the new infrastructure being built today, you first have to look at how the actual workload of AI has fundamentally changed.
Right, because for the last decade, we lived in what developers call the 12-factor application era.
Yeah, the old reliable standard.
Application servers were built to be stateless and synchronous. You make a web request, the server quickly queries a database, and it returns an answer in, like, milliseconds.
Sub-second execution.
Very fast. Exactly. Sub-second. And if the server crashes for any reason, you just refresh the page and try again. It's incredibly fast. But the server has absolutely no memory of what it was just doing.
And that's the problem, because AI agents completely break those legacy rules. They aren't just answering a single, simple question anymore.
No, they're doing actual work.
Right. Agents are non-deterministic. And by that I mean, if you ask an agent to perform a complex task twice, it might take two entirely different reasoning paths to get to the solution.
It's not just a predictable, hard-coded API call.
No, not at all. Furthermore, they are long-running, and they operate in these complex asynchronous loops.
Yeah, think about a real-world enterprise agent. It might need to draft a financial report, query 3 different secure databases, and then, and this is the kicker, send an email to a human manager for approval before it can take the final step of publishing the data.
And human approval does not take milliseconds.
Exactly. That process could take minutes, hours, or, if that manager's on vacation, it could take days.
Right. And if you attempt to run a multi-day process like that on a traditional application server, the moment that server experiences a slight network hiccup,
which happens all the time,
or if it just times out after its standard 30-second window, the agent dies.
Just poof, gone.
Poof. All of that complex reasoning, all of those incredibly expensive token API calls it made to figure out the problem, they just vanish into thin air.
So let me make sure we are anchoring this concept because it's basically the foundation for everything else we're discussing today.
Yeah, it's the core shift.
The old way, the legacy app server,
Yeah.
is basically like a short order cook in a diner. They are incredibly fast, flipping burgers at lightning speed, but if the power flickers and the lights go out for a single second, they forget your order completely.
You have to walk back up to the counter and start over.
Exactly. But these new agent runtimes the industry is pivoting to, they are more like a meticulous project manager.
I like that analogy.
Right. They write every single action down in a ledger. step by step. So if they
Yeah.
get interrupted or the power goes out, they don't panic. They just open the ledger, read exactly where they left off, and pick right back up.
Yes. And the technical term for that ledger is an event history journal.
Event history journal.
Right. And it is the core mechanic of what we call durable execution frameworks. We're seeing a massive surge in technologies like temporal, DAP, and AWS step functions specifically for this reason.
So how does that work in practice?
Well, let's say your AI agent crashes midway through a complex 10-step process. When the system eventually restarts, it begins to replay the workflow.
Okay.
But here's the magic of durable execution. When it gets to step 1, which might have been, say, a $50 LLM query,
Ouch, yeah.
it doesn't query the model again. It sees the result securely logged in the ledger and instantly returns the cached result.
Oh, wow. So it does the exact same thing for step 2, like writing data to a CRM database.
Exactly. It doesn't duplicate the database, right? It just pulls the receipt from the journal.
So it does not consume new compute tokens, and it does not duplicate real-world actions until it reaches the exact point of failure.
Spot on. That reliability is mandatory for enterprise adoption. And because these durable runtimes are effectively the new application servers, the major hyperscalers, the big cloud providers, have been in an absolute arms race to build them.
Yeah, we're definitely seeing that.
But looking at our sources, particularly the hyperscaler architecture matrices, they seem to have copied the exact same blueprint.
I mean, we are seeing AWS Bedrock AgentCore, Google Gemini Enterprise Agent Platform, and Microsoft Foundry Agent Service all hitting general availability around this mid-2026 window.
All at the same time.
Yeah, and they have all converged on a nearly identical 7 primitive architectures, like 7 distinct pieces of infrastructure that every single enterprise agent needs to function.
What's fascinating here is the sheer level of architectural convergence. You can lay their technical documentation side by side, and it reads like the same document.
It's kind of wild.
It is. Every cloud provider now offers a runtime engine to handle the loops. They offer a memory primitive, usually a managed vector database, for state persistence.
Right, they have to remember things.
There's a tool gateway to manage API access, an identity layer to track who the agent is, observability to monitor the agent's thought process.
And evaluation, right?
Yes, evaluation to grade the agent's performance, and finally, a governance or policy primitive to enforce guardrails.
We should pause on a couple of those because
Yeah.
they really illustrate why this is a whole new software paradigm.
Definitely.
In the old days, evaluation was just writing a unit test in your code. You input A, you expect B, done.
Simple, predictable.
But with agents being non-deterministic, you can't write a standard unit test. You actually need a separate AI model acting as a judge to evaluate if the first AI model did a good job.
Which is wild if you think about it.
It requires entirely separate, dedicated infrastructure. And the same goes for memory. Context windows on these models aren't infinite, so you need a dedicated primitive to store and retrieve long-term state.
Yeah, the convergence is undeniable at that primitive level. But, and this is a crucial distinction for anyone currently mapping out an IT or cloud strategy, that convergence is completely superficial when you look at portability.
Wait. If AWS, Google, and Microsoft all built the exact same 7 pieces of infrastructure doing the exact same jobs, you would assume you could just take your custom AI agent, pack it up, and move it freely between the clouds.
You would assume that, yes.
So why can't a company just drag and drop their agent from Azure over to AWS if they find a better price?
Because the lock-in has fundamentally moved.
How so?
Well, 2 years ago, the lock-in was all about the model. You were trapped in the ecosystem of whoever made the smartest large language model.
Right, everyone was chasing the smartest model.
But now, the baseline frontier models are largely interchangeable. The new lock-in is the control plane itself.
Oh, I see.
Yes, all 3 clouds have an identity primitive. But an agent built on Microsoft's platform is deeply tethered to Microsoft Entra ID. An agent on AWS is intrinsically tied to AWS Cognito.
Oh, man. So your agent is also tied to specific telemetry syncs for that observability primitive we mentioned, like AWS CloudWatch versus Azure Monitor.
Exactly.
And the memory formats, like how the agent actually stores its long-term state, are entirely proprietary. You cannot just extract an agent's memory banks and drop them into a competitor's cloud format.
They have basically built identical hotel rooms, but the keys only work on one specific brand of doors.
That is incredibly frustrating for developers.
It really is. And because this hyperscaler lock-in is getting so intense at the control plane level, the open source community is actively fighting back.
They usually do.
Yeah, they are pushing out standardized protocols to ensure agents can at least communicate and use external tools freely, regardless of which cloud hotel room they happen to live in.
And this is where the ecosystem reports in our stack get really interesting. We are seeing the rise of two critical standards, both of which now sit under the Linux Foundation's Agentic AI Foundation.
The first is MCP, or the Model Context Protocol. MCP standardizes how AI models access enterprise data and tools. So instead of a developer writing, custom integration code for Salesforce and then different code for Slack and different code for an internal database,
Which takes forever.
it does. Instead, they just build a single MCP server. Once that server is up, any compliant agent can talk to it seamlessly.
That makes so much sense.
Okay.
And the second major standard is A2A, standing for agent to agent. This protocol standardizes how different autonomous agents collaborate and delegate work to each other across different networks.
Yeah, and they accomplish this using structured JSON schemas called agent cards.
I love those. Those agent cards are brilliant.
They really solve a massive communication problem.
Yeah, think of them as a resume and an instruction manual rolled into one machine-readable document. Since one agent can't just talk to another agent in plain English and hope they understand the nuance of an API requirement.
That would just break instantly.
Right. So the JSON schema explicitly outlines exactly what inputs the agent accepts, what outputs it guarantees, and what permissions it holds. It tells other agents exactly how to interact with it safely.
It is a visionary approach for an open ecosystem. However, this level of dynamic open connectivity introduces a terrifying security reality.
I was waiting for the catch.
Yeah. When you allow autonomous AI agents to dynamically discover and connect to external tools and other unknown agents on the fly, you exponentially increase your enterprise attack surface.
I mean, our sources highlight a very specific systemic security crisis that emerged from this openness. Researchers discovered massive remote code execution vulnerabilities in MCP's STDIO transport layer.
Just brutal vulnerabilities.
For context, STDIO stands for Standard Input Output. It's the most basic, fundamental way processes on a computer talk to each other.
Right.
And the vulnerability tracked is CVE 2026, the BED623, exposed millions of systems to supply chain compromises. Why? Because agents were basically reaching out and grabbing whatever external data they wanted without proper sandboxed security checks.
And the fallout from that vulnerability forced the industry to rapidly invent and deploy a new architectural component: centralized MCP gateways.
So no more free-for-all.
Exactly. The days of allowing an autonomous agent to hold a long-term API key in its own memory are over. It is simply too dangerous. Instead, all tool requests now have to pass through a reverse proxy.
Reading through these architecture diagrams, the MCP gateway acts exactly like a heavy-handed bouncer at a VIP club.
That's a great way to picture it.
Let's say an agent wants to pull a sensitive customer record from a database. It doesn't hold the password. The agent walks up to the gateway and asks for the data. The gateway stops the request completely. It validates the agent's identity against the central corporate directory, acting as that bouncer checking the list.
Once the identity is confirmed, the gateway checks the role-based access control policies to verify if this specific agent is actually authorized to view customer records.
Right. Is it allowed to be in that room?
Exactly. If the policy allows it, the gateway itself dynamically injects a short-lived, temporary secret just in time. It executes the tool call on behalf of the agent, returns the sanitized data back to the agent, and securely logs the entire action in an immutable audit trail.
So the agent never touches the actual database credentials.
Never.
It is a highly effective way to secure the perimeter. But security in the modern enterprise isn't just about stopping hackers and patching standard transport layer vulnerabilities.
No, not at all.
When you are dealing with massive global enterprises, security is heavily influenced by geopolitics. It involves legal jurisdiction and data sovereignty, which transitions us to the massive expansion of the Microsoft and Mistral AI partnership that was just announced days ago on July 24th, 2026.
Yeah, the details of this expansion present a fascinating study in factual geopolitical strategy. Looking at the terms of the deal, Microsoft is pouring billions of dollars into funding Mistral's European data centers.
Wow.
They are outfitting these facilities with next-generation NVIDIA Vera Rubin GPUs.
Which are not cheap.
No, they're not. And in exchange, Mistral's latest models, specifically Medium 3.5 and OCR4, become first-class citizens inside the Microsoft Azure ecosystem.
Okay, that's it.
Crucially, this partnership allows those specific models to be deployed via Azure Local in fully disconnected, air-gapped environments.
Okay, I have to push back on the business logic here for a second.
Sure.
Microsoft already has a massive catalog of proprietary and open models. They obviously have their own sprawling global data center footprint. Why would they spend billions of dollars building up a direct competitor's European infrastructure, especially when the reports explicitly note Microsoft is taking absolutely zero new equity in Mistral? What is the actual play here?
It is a highly calculated regulatory hedge. By partnering with an independent European entity like Mistral and running the compute on Mistral's physical metal, Microsoft successfully bypasses a major regulatory hurdle.
Which is?
The U.S. Cloud Act.
The U.S. Cloud Act is the law that essentially dictates U.S. authorities can demand data from a U.S. headquartered cloud provider,
Right.
regardless of where that data physically lives.
Exactly.
So even if a German bank's data is sitting on a server in Berlin, if that server is owned by a U.S. company, U.S. law enforcement can theoretically compel access to it.
Yes. And for highly regulated European industries like defense, healthcare, and finance, that jurisdictional reach is a complete deal breaker.
I can imagine.
They require absolute legal isolation to comply with the strict requirements of the EU AI Act. By routing these sensitive enterprise workloads through Mistral's independent corporate infrastructure, or by allowing enterprises to run these models in their own completely disconnected Azure local environments, Microsoft bridges a vital gap.
That's fascinating.
They separate data residency, which is where the bytes literally sit on a hard drive,
Right.
from data sovereignty, which dictates who actually has legal jurisdiction over those bytes.
It is a brilliant way to thread the needle. I mean, Microsoft gets vital GPU capacity in a region where power and compute are scarce. They position themselves as champions of European sovereignty without triggering antitrust alarms by trying to buy Mistral outright.
Exactly. They stay out of antitrust trouble.
And most importantly, they give their heavily regulated customers a way to run cutting-edge frontier models without the anxiety of foreign government overreach.
It is an elegant solution to the sovereignty problem. However, even if an enterprise manages to vertically navigate the durable infrastructure, the control plane lock-in, the open source security gateways, and the geopolitical hurdles.
There's a lot of hurdles.
It is. But this massive restructuring of enterprise software ultimately crashes into one very painful, very practical wall:
Let me guess.
the unit economics.
The bill. Always the bill. The financial reports in our stack show that the unit economics of AI are fundamentally breaking right now. Year over year, the actual price of a token, the raw unit of AI compute, dropped by roughly 67%.
Compute got significantly cheaper.
And yet, simultaneously, enterprise AI bills are rising sharply. They're skyrocketing across the board.
The cost is rising because the underlying workload changed. If we connect this to the bigger picture we established earlier, we moved from stateless chatbots to durable agent loops. When a user interacts with the chatbot, it is a linear transaction. One prompt in, one response out.
Very simple.
But when you deploy an autonomous agent, it performs recursive reasoning. It tries a tool, fails, thinks about why it failed, tries a different tool, summarizes the result, and plans the next step.
And the metrics show that agents consume 5 to 30 times more tokens per task than a standard chatbot.
It's massive.
And here's the most staggering statistic from the financial analyses. Up to 62% of an enterprise's AI bill right now is generated entirely from recent context.
That is just wild to think about.
Because the AI model doesn't have a persistent human brain, every single time it takes a new step in a long workflow, the runtime has to bundle up and resend the entire history of everything the agent has done so far just to maintain context.
Yeah.
It is the equivalent of having to reread an entire novel from chapter 1 every single time you want to turn the page.
Which is incredibly inefficient. And this raises an important question for IT leadership. If you are burning compute at that rate, how do you scale?
You can't.
The answer we are seeing across these reports is the mandatory adoption of agent FinOps. The old industry metric of looking at your cost per token is dead. It is an utterly meaningless metric in an agentic workflow.
So what's the new metric?
The only metric that matters now is your cost per successful outcome.
Oh, that makes sense. If an AI agent burns through $5 of API tokens to automate a data entry task that used to cost 50 cents of human labor, you aren't innovating, you're just lighting your IT budget on fire.
Exactly.
So what does this all mean for daily operations?
It means enterprises must adopt aggressive model routing. You can no longer afford to send every single API call within an agent's loop to a massive, expensive frontier model.
It's just too pricey.
Right. The successful enterprises are utilizing cheap, open-weight spot models. Think of these like spot instances in traditional cloud computing, transient, highly inexpensive compute power that is perfectly adequate for basic tasks.
Oh, okay.
They route 98% of the repetitive agent steps, like formatting dates, extracting simple JSON schemas, or summarizing short text to these spot models.
Which cost almost nothing.
Exactly. They only route the highly complex 2% of tasks, the deep strategic planning and orchestration to the expensive frontier models.
You have to build that routing discipline into your infrastructure, or these recursive agent loops will basically bankrupt you.
Absolutely.
Well, let's wrap this up and summarize the journey we have taken you on today. We started with the realization that traditional app servers are out, and durable runtimes utilizing event history journals are the new foundational layer.
We examined how the major hyperscalers have converged on the same 7 primitives, effectively shifting vendor lock-in from the model layer to the control plane.
We explored the open source pushback through protocols like MCP and A2A and how centralized MCP gateways are securing that new frontier.
We navigated the geopolitical complexities of the Microsoft and Mistral sovereignty hedge.
And finally, we broke down the harsh FinOps reality of agent loops, illustrating why sophisticated model routing is your only defense against runaway cloud consumption. Armed with these insights, you have a massive strategic advantage heading into your next tech strategy meeting.
Before we sign off, though, there is one final critical insight hidden deep in these sources that we haven't touched on, and it is something you really need to ponder. The reports label it the shadow agent sprawl.
This is a wild concept.
It really is.
We are rapidly moving toward a business environment where autonomous agents possess what researchers call ambient authority. They are acting on behalf of humans, executing high-stakes financial trades, making medical triage decisions, or modifying supply chain orders in the background 24 hours a day, 7 days a week.
And if enterprises do not immediately begin building an assurance inventory of their agents, like a strict auditable registry detailing exactly what agents exist on their network, what tools they have permission to access, and who ultimately owns their outcomes,
It's going to be a disaster.
they are going to wake up to a chaotic web of opaque, unauditable machine actors running their businesses entirely in the shadows.
You definitely do not want to build a 50-story skyscraper out of Post-it notes, but you also do not want to fill that skyscraper with invisible workers you cannot monitor or control. Build your foundation right. Thank you for joining us on this deep dive into the agentic economy. See you next time.